Greetings, mathematicians of all ages. Today our lesson is look for a pattern. You may ask, how is that different than patterns in number sense? Well, with patterns we were mostly just looking at numbers and trying to find the number pattern. Today our goal is to kind of move that into the word problem arena and use what we learned in the last lesson of patterns in number sense to be able to solve word problems more quickly. Kind of a classic example of that is, say you have some kind of ping pong tournament. Yeah, we can go with that. It can be any sport really. And you say you have so many people in the tournament and each person has to play one other person once. Now if you don't like sports, it could be you have so many people at a party, everyone has to shake hands with every other person. And you get it. It's the same idea. So let's just start with a really basic example and let's kind of take the old approach. The old approach probably is to draw a picture or some numbers to represent the players in the tournament. And let's just say for this example, there are 4 players in the ping pong tournament. I'm going to do my best to make 4 ping pong paddles. Maybe it needs to flare out a little more. Maybe that's closer, maybe not. Maybe a bigger top. Good enough. All right, let's say we have, these are our players, our first player, second, third player, and fourth player. And probably a way you'd consider doing it in the past is, I'd start with player 1 and say, well, player 1 has to play player 2, player 3, and player 4. So that's already 3 games. And then if I jump to player 2, I'd say he has to play player 3 and player 4, and he's already played player 1, so I don't need to include that one again. And that's 2 more games. And the only game that's left, because player 3 has already played player 1 and player 2, etc., the only game that's left is for 3 to play 4. So that's 1 more game. And we can add those up and get 6 games total. Now this works. It's a perfectly good method. The issue is when we get to a tournament with 7 people, and now let's say, rather than me attempting to try to draw anything else, let's just make it numbers. So let's say I have 7 people in this ping pong tournament. So let's get those in. And now you can see how this will quickly become, I would say, semi-daunting. You know, player 1 has to play player 2, 3, 4, 5, 7, and then you jump to 2. And it's all this stuff and making sure you remember which which has gone where, and you know, having good enough handwriting to not mess all that up. And you could keep track of it all over here like we have. But if you want to extend it to 8 players in the tournament, you'd have to redraw it and do it all over. So I think a better option is what the section is called, which is look for a pattern. So the way we do that is, let's get a clean sheet here. All right, the way we do it is, we're just going to say, we're going to take basically so many players in each tournament, and we're just going to increase that by 1 each time. And so I only have to do that drawing it out probably a couple times. So in a tournament with 1 player, it wouldn't be a terribly exciting tournament because they win without ever having to hit a ball. So let's start with a 2-player tournament. And in a 2-player tournament, you can probably see that since there are only 2 players, this player and this player, they play each other, and that's it. That's the whole tournament. So that's 1 game in that tournament. If we had a 3rd player, we have this game still, a 2nd game, and a 3rd game, and now they've all played each other. So that's 3. In a 4-player tournament, we did that before. Let me jump back to that here. In our 4-player tournament, you remember there were 6 games, right? And you may start to see a pattern in this, maybe not yet. So why don't we just quick do a 5-person tournament. Let me erase these X's. So in our 5-person tournament, 1, 2, 3, 4, 5 people. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 games. Okay. Now maybe you can start seeing a pattern so that I can get up to my 6th and 7th games as well. If you don't, I guess I'm just going to tell you. If you look at what changes from here to here, and then here to here, and then here to here. In yesterday's lesson, our goal was to find something that always happens. The same thing is happening each time to that number. So I can always say, remember, start with 2 and multiply by 3 repeatedly. So I'm always multiplying by 3, or start with 29 and subtract 2 repeatedly. So I'm always doing the same thing. In many of these patterns, we don't necessarily have that repeating option, but there's still a pattern. So if you look, you can see from 1 to 3, we're adding 2. And from 3 to 6, we're adding 3. And from 6 to 10, adding 4. So then, if we just extend the pattern a little further, if we're adding 5, that means our 6-player tournament is going to have 15 games, and our 7-player tournament is going to have 21 games. So we did that all by looking for this pattern, something like that. And of course, we could keep going. An 8-player tournament, a 9-player tournament, a 10-player tournament. And that's why this is useful, because in the old way, I'd have to redraw all 8, and that would take plenty of time. But now, since my last one was adding 6, that means to go from here to here, I'm just going to add 7, which gives me 28 games, adding 8 to get to 36 games, and then adding 9 to get to 45 games. And I could keep going. There might, I don't know, there's probably bigger tournaments out there. Although in real tournaments, you probably don't play everyone once. Anyway, that's one example of how you can use a pattern to solve a word problem. And now let's just take a look at one more example of how you can use patterns to solve a word problem. So in this example, we're going to say a TV station has a call-in contest. And on the first day of the contest, so we'll say it'll go 10 days. And on the first day of the contest, the first caller wins. So let's just get that down. So on the first day, the first caller wins. On the second day, the second caller wins. And you probably think you know where this is going, but let's look at a few more. On the third day, the fourth caller wins. And on the fourth day, the 8th caller wins. So if we jump back a few steps, you can probably see that a potential, before I added these, let's get rid of these. Before I added the fourth day, the 8th caller wins, you could have said, a lot like the last pattern, +1, +2, and if we extended that, that means on the fourth day, the 7th caller would win. But since I said on the fourth day, the 8th caller wins, now we got to look for a different pattern. And this is a lot like yesterday's, where we have something repeating, right? So hopefully you can see our pattern is ×2. And now that we figured out the pattern, we can really answer any question they have about this call-in contest. So they could ask the question like, will the 20th caller ever win? Right? And if we extend it, we see ×2 will give us 16, ×2 will give us 32, ×2 will give us 64, and we realize it won't, because the 20th caller would have to happen somewhere in here, but if we're just going day by day, it's only going to ever increase and get bigger and bigger and bigger down this way. So that 20th caller would never win, right? They could ask us a question like, on the 10th day, which caller is winning? And apparently it must be a pretty popular contest if they're going to get this many callers, because if we go ×2, if we do 64 ×2, we're going to get 128 up here, 256 on the 9th day, and the 512th caller on the 10th day. I suppose they could get up to 512 callers. I guess it depends on what the prize is. Maybe a new car will get you up there. A new baseball might not get you that high. Anyway, so there's two examples of how you use patterns to solve word problems and to save yourself a bunch of time. See you next time.